Hi everyone, I am Polash Kumar Bora. Today I will talk about uh, some concept of set theory, and here I will start by taking the definition of finite set. What is finite set? A set consisting of finite number of elements is called a finite set. Okay, that means we can count the total number of elements present in that set. As an example, we can take set A, suppose consists of some elements. Those are suppose 1 to 4, 8. Then these are finite because we can count all the number of elements present in the set. Let me consider another example, the set of vowels, and those are A, E, I, O, U. Again, we can count the total number of vowels present in the set, and those are 1, 2, 3, 4, and 5. So that is a finite set. Let me consider another example. Suppose x such that x is a solution of this equation, x squared plus 5x plus 6 is equal to 0. And if we want to solve that equation, then we are doing it by middle term break, and then we found the value of x to be -2 and -3, and so the set B is -2 and -3. That means we can say the set consisting of two elements, so it is a finite set. Okay, let me talk about infinite set. The word itself is saying the definition. A set consisting of infinite number of elements is called an infinite set. Okay, that means we cannot go on counting all the elements present inside the set. Okay, as an example, we can say the set of natural numbers. If I talk about set of natural number, then we have infinite number of natural numbers. That means if we go on counting from 1, 2, 3, 4, 5, 6, and this process never ends. That's why it is an infinite set. And the symbol we are using to represent the set of natural number is this symbol, and this is the standard symbol used to denote set of natural numbers. And second example, we can take the set of integers, and that is also infinite. That means if we count all natural numbers and it's negative together with 0, and that constitute the whole set of integers. And the standard symbol to represent set of natural numbers is either Z or I. Let me consider another example, the set of real numbers. That is also an infinite set, and the standard symbol to represent the set of natural number is this R. Okay, let me talk about cardinal number of a set. And when we'll be talking about cardinal number of a set, we'll be talking about cardinal number of a finite set. Okay, now the total number of elements present in a set is known as the cardinal number of a set. That means whatever the elements present in a set, and that total number will be known as the cardinal number. Okay, what is the notation we are using to represent cardinal number of a finite set? And the cardinal number of a set A is represented by this symbol Na. Okay, let me take one example, 1 to 4, 8 as the elements of the set A. Then the cardinal number of the set A will be 4. Okay, because it has 4 elements. Okay, fine, it is clear. Okay, let me talk about subset and superset. A set A is said to be a subset of a set B if every element of A is also an element of B. Okay. If A is a subset of B, then this is a symbol we are using to represent, okay, to A subset of B. Now when A is a subset of B, then we say B is a superset of A, and the symbol used to represent B superset of A is this symbol. Okay, let me consider one example. Suppose A consists of alpha, beta, gamma, and B consists of 1, 2, alpha, beta, gamma. Now if you observe the set A and B, the elements of the set A are also the elements of B, as you can see here. All elements of A are also the elements of B. So from here we can say A is a subset of B. Now, if A is a subset of B, then B is always said to be the superset of A. Now, just you have to simply remember that the elements of B or the superset consist of more elements than the subset. Okay, that is the thing you have to remember. Okay, now let me talk about equal sets. Two sets A and B are said to be equal if every element of A is a member of B and every element of B is also a member of A. That means sorry, this is the meaning of A equal to B. If A is equal to B, that means we can say every element of A is also a member of B. Then from that we can say A is a subset of B, and every element of B is also a member of A. That means we can say B is a subset of A. If both these two conditions are happening together, that is A subset of B and B subset of A, then we say A is equal to B. Now let me talk about equivalent sets. Two finite sets A and B are said to be equivalent if they contain same number of elements. Okay, that is Na is equal to Nb. This is a symbol we are representing to denote A equivalent to B. A equivalent to B means, always remember, the number of elements present in A is equal to number of elements present in B. Okay, let me consider one example, then it will be completely clear to you. Suppose A consists of 1, 2, 3, 4, B consists of alpha, beta, gamma, delta, and C consists of 3, 4, 1, and 2. Now, if you observe A and C, the elements of A and elements of C are exactly the same element. So from here we can say A and C are equal sets. But if you observe A and B, they they contain same number of elements, not the same elements, so A and B are equivalent. Similarly, B and C contains same number of elements. I am emphasizing the word number. Same number of elements, but not the same elements, so B and C are also equivalent. So we can say A equivalent to B and B equivalent to C. Okay, what is power set? Okay, let me consider a definition. The collection of all subset of a set A is called the power set of A, and it is denoted by PA. As an example, you can see A consists of 1, 2. Then the subsets of A, always remember, by default, always remember, if I have any set, this is the symbol to represent empty set. Empty set is represented by the symbol phi, and phi is considered to be the subset of all sets present in the world. Okay, and if I consider a single element 1, that is also a subset of A. Single element 2 is also a subset of A, and overall 1 and 2, that means whole set A is a subset of A. Why? Because every element of this set 1, 2 is also the elements of A, so that's why this is also a subset of A. Now, if I collect all of these, then this is known as the power set of A. Now, if you observe, this is the observation that you have to keep it in your mind. A consists of 2 elements. Then you see how many elements are present in power set. There are 4 elements. Then power set is having 4 elements. So that we can write as 2 square. Keep it in your mind, okay? Let me consider one more example. Suppose A consists of alpha, beta, gamma. Then you try to write all subsets of A. By default, phi is a subset. Now consider single element at a time. All these are also subset of A. Now you try to collect 2 elements at a time. Alpha, beta, then alpha, gamma, then beta, gamma. These are also subsets of A. And at last, The all elements alpha, beta, gamma is also a subset of A. Now if I collect all of these, then this is known as the power set of A. Now this is the observation you have to keep it in your mind. If A consists of 3 elements, now you try to count the number of elements present in the power set. Then if I count 1 2 3 4 5 6 7 8, so it has 8 elements. Then the number of elements in the power set is 8, and that can be written as 2 cube. From here we can give a very interesting relation between the number of elements present in a set and the number of elements present in a power set. If A consists of m elements, then the power set will be consisting of 2 to the power m element. This is one of the very important results that you have to keep it in your mind. That's why I am putting this inside the box. Okay, fine. Now let me talk about universal set. So a set which contains all sets in a given context is known as the universal set. That means simply you have to understand that the set which is the boss of all set. That means inside that set all other sets are present in a given context. Okay, in a particular situation, then we say it is a universal set. As an example, we can take, suppose A is equal to 1 to 5 and B as 3 4 8 9. Then for these two sets we can consider this to be the universal set. Why? Okay, under this situation, under this particular example, we can say A is a subset of B and B is a subset of U. So U is the boss of A and B, so we can say U is the universal set. Okay, just simply you have to remember that the set which is the superset for both the sets or whatever the sets we are considering, then U is said to be the universal set. Okay, now one very important concept that is known as the Venn diagram. By understanding these diagrams, we can understand the concept of set theory very easily, or the things becomes more clear when we talk about Venn diagrams. Okay, this is the rectangle which is used to represent universal set, and the circular shape or the oval shape is used to represent any kind of set. Okay, if I take one example, then it will be, I think, more clear. Suppose I have a universal set and the set A and the set B. Now if you observe these sets, U is the boss of A and B. That means U is the superset of A as well as the superset of B. For the universal set, as I said, we are using the rectangular shape to represent it. Let me draw the rectangle to represent universal set, and here A is, these are the elements 2 4 6 8 9, and B is a set and those, and some elements are common to both A and B, those are 2 4 9. Okay, this is the representation which is for U, A and B. Okay, let me talk about some operations on set theory. Like we have operations of two numbers like addition, subtraction, multiplication and division. In the same way, we can also operate two sets. And the first operation is known as union. Okay, before going to the formal definition, let me talk about one example. Suppose A is 2 4 6 8 9, B as 2 4 3 5 7 9. Let me draw that Venn diagram for these two sets. I am highlighting all the elements here. Then this is the set A, and why I am putting this element inside A, because A consists of 2 4 6 8 9 and B consists of these elements. Now from here, what does the union mean? That means the shaded portion, the elements present inside the shaded portion is known as the this union of these two sets A and B. So we can say A union B is the elements which are inside the shaded portion. If I talk about the elements inside the shaded portion, and those are 2 4 6 8 9, 3, 5 and 7. These are all elements. That means I can simply say all elements present in A as well as present in B, with the common elements writing only once. So from here we can define union of two sets as A union B is a set of all elements either from A or from B or from both. Mathematically, the A union B is written as this: A union B is equal to X such that X belongs to A or X belongs to B. Okay, I'm putting inside the box. That means it is very important and you have to remember this. Okay, let me go to intersection of two sets. This is another operation of set theory. Okay, in the same way, let me consider the example first, then I'll be going for the formal definition. This is the Venn diagram, and intersection means the elements present in the shaded portion. That means those are the common elements between A and B. So I can say A intersection B is nothing but it is 2, 4 and 9. So definition is like this: A intersection B is the set of all elements which are common to both A and B. And mathematically we are representing A intersection B by this one, and for union we have the or there, and for intersection always remember in place of or it is and so it is X such that X belongs to A and X belongs to B. Okay, let me talk about difference of two sets. The same way, let me consider the example first. If I talk about A difference B, okay, again, A difference B means all elements present in A which are not present in B. That means you cut off all elements of B. This. So A difference B is equal to 6 and 8. So what is the formal definition? A difference B is a set of all elements from A which are not present in B. That means you have to eliminate all elements present in B. So A difference B mathematically we used to write as X such that all elements from A but those elements are not present in B. Okay, let me talk about complement of a set. Okay, to define complement of a set we need one universal set, and set A is a subset of this universal set. Let me talk about the Venn diagram. Okay, I'm keeping some time here so that you get the idea of the picture or the Venn diagram. Okay, A consists of 2, 4, 6, 8 and U consists of all these elements. Now if I want to talk about complement, then simply all elements of A will be eliminated from here. Yes, this. So I can write A complement as 1, 3, 5, 7 and 9. That means all elements present in U which are not present in A. So that means it is the difference, U difference A. So the formal definition goes like this: if U is the universal set and A is any set, then the complement of A is a set of all elements from U which are not present in A. Okay, so mathematically we used to represent A complement by this: A complement is equal to U difference A, and it is X such that X belongs to U but X does not belong to A. Okay, I will stop here. If you have any kind of queries or if you find any difficulty in understanding, you can ask me, you can message me. Okay, be safe, be healthy. Thank you.